All right, guys, welcome to another episode of CUDA Education. We are on our grind. Um, so we're continuing our journey of this RayGen shader. A couple of things I've kind of discovered, and as we continue to learn the Vulkan API. First of all, as you guys know, we compile this shader. This is a separate shader from the script, right? So we have the ray tracing basic.cpp, which is the main script, of course, for our triangle, and then we have an external shader, raygen argen SPV. But in order to get to this SPV file, we have to compile this argen file, right? And if you've been following along, you know that the argen file, this argen file here, is as part of the solution for ray tracing basic, and we compile it using Python, and that when we compile it using Python, we get the .spv file, which is the SPIR-V file, right? So SPIR-V is Kronos Group's proprietary kind of baseline driver language, blah blah blah. Okay, all right. So what I've kind of learned with experimenting with this whole situation is that, number one, once I run the compile shaders.py, once I do the compile shaders thing, I just have to start without debugging. I just have to basically run the script, right? I just have to run the script, right? So I just run the script. I don't have to rebuild ray tracing basic, because the argen, this SPV file is separate and apart from what we have here. Okay, I'm not a philosopher and a psychologist and all that into this stuff, but I'm just letting you know that once we run the Python script to compile this SPV file, you could just go straight directly and run the script, right? So anyway, so for this video, we're just continuing our journey of understanding the argen shader. Okay, I don't really want to start diving into the other shaders, because if you look here, you will see you have the raygen shader, you have the miss shader, and you have the hit shader, closest hit shader, right? Which is whatever, right? Miss shader and closest hit. But I want to just stick with the ray generation, because I think it's the most interesting and the most fun, and kind of just fully understand the raygen shader as for the time being, right? So and then continue to investigate as we go along. So we already played around with this tmin and tmax, right? And we know that tmin and tmax represents the distance from where the where the ray is generated to the minimum distance from where the ray is generated to the maximum distance from where the ray is generated. So basically, how what intersections do we count? So the reason why they do tmin of it's not a flat zero, but it's 0.001, the reason why they don't do it at a flat zero is because the raygen surface could be, it could have a lens or a film. I don't know. That's just how I view it in my head. But it could have some kind of other thing inside of the raygen mechanism. So you don't want to count things inside of the device, right? So if it's inside of a lens or something, you don't want to intersect your own camera lens and then say, oh, we hit something, but it's really just your own camera lens, right? You don't want to do that. So you want to have a little separation between where the ray is initially generated and where you start counting intersections. So that's why it's never a flat zero. And then, the original script has 10,000 units of distance away from where the ray was initially generated. So anywhere from 0.001 to 10,000, we count any intersections the ray hits. If anything happens outside of those bounds, if you get intersections outside of those bounds, we don't count it, we don't see it, we don't know about it. It's discarded, it's null and void. We don't care. All right. The other thing that we learned was that the camera, sort of the realm of what is captured is sort of is sort of the scope of what is captured is sort of done as a result of a sphere, right? Because it's equidistant. So this distance and this 10,000 distance is an equidistant thing. So an equidistant in 3D modeling, an equidistant distance from a point is you basically generate a sphere. So you generate 10,000 units away, facing north, south, east, west, x, z, internal, external, everything. So it's a sphere. So when we zoom in, depending on how you play around with this Tmax, when you zoom into our proverbial triangle, if it's not seen and then you zoom in the camera so it could be seen, based on where the geometry of the triangle is drawn, you're going to start to see the center, and then as you zoom in more, you see more and more of the triangle fleshed out, right? But that was discussed in the previous two videos, where I want to discuss this hit value thing. Okay, so hit value is basically, from what I understand, hit value is basically sort of it's recording the hits. Okay, so it's recording the hits that have occurred, and that's where this rayPayloadEXT comes in. So you generate a payload, and then you generate a ray, right? And then associated with that ray is what they call a payload. Now, a payload is simply it's record keeping. So it's like a database, right? It's like, okay, we've generated a ray, and then we have to record anything that this ray hits. Okay, so we generate a ray, and we have to record anything that the ray hits, right? So that's where this rayPayloadEXT comes in, right? So that's pretty much what this hit value variable is about, right? So it's a 3D vector, right? It stores color, position, or other vector data associated with ray intersections, right? Right. So, in this, I think in this context, it's representing, if there's a hit value, it changes the color, right? So we have a color of some sort, right? So if it doesn't hit anything, of course, we have our sky model. But if it hits something, it changes the color. So it's a 3D variable. And we could kind of see that here, vec3, right? So it's a vec3, and then the variable name is hit value. All right, rayPayloadEXT, right? So we also know that it's rayPayloadEXT. And this variable is in location 0. Now, what is location 0? Location 0 has something to do with the acceleration structure, right? Which makes sense. I'm going to hesitantly say it's associated with this guy here, right? So location 0 is let me see if all right, so all right, so for right now, we have location 0, hit value, and we're gonna say it's part of the acceleration structure, which kind of makes sense just from looking at it, right? So we have location 0, we have a hit value variable of vec3, and we have a rayPayloadEXT. So that's this guy here. That's our hit value. And then what happens is that we initialize the value of hit value to 0, 0, right? So vec3 0, 0. So everything is, the vector is empty. It's all zeros, right? And then what we do is we basically use the hit value in this image store. We use this value in this image store variable. And I'm just going to assume that this image store variable has something to do with our storage image, which basically eventually makes its way to the swap chain. Right, so it's writing data to an image. This image store, it's a built-in function in Vulkan GLSL shaders. And it allows, let's right, so I mean, let's just leave image store. Let's just leave that conversation right there about image store, right? So okay, so the parameters is the image, which is this guy here. Do we mention image anywhere else in the shader? Okay, so the image is this guy here, right? Uniform image. Okay, so the parameters are image, the coordinate, which I'm not even going to get into this right now. I'm not going to get into it. So we have the image, the coordinate, and then the data. So the data now is basically a concatenation of the hit value, which is a vec3 of 0, 0, 0, and then we add another 0, 0. So I think this image store function takes 4. It takes a vec4, right? So we have vec3 here, and then we had to add another one to make it vec4, right? So, and that's why this vec4 function is here. But anyway, that is not the focus of this video. The focus of this video is this hit value, right? And also just the fact that it's rayPayloadEXT, right? So we initialize a variable here, but it's initialized, but it doesn't have any sort of data in it. And then we basically fill it up with all zeros, and then we drop it into our image store function, which is the storage image and the swap chain, and basically makes its way to what we see on the screen. All right, so that's that's that. So I'm just gonna run my script. I'm just gonna run the script normally. So here we have our triangle. I think it's distance of 10,000. So we zoom all the way out. We zoom all the way in. And we basically have our triangle, right? It doesn't, the intersection is there. So we know that already from the previous videos, okay? So then now we have our hit value, right? So obviously the the hit value is being updated. So basically the ray is generated from the camera, and then once it hits this geometry, it's recorded as a hit. So because it's recorded as a hit, we get to see the triangle, right? So makes sense. Okay, but we're CUDA education, right? We're interested in learning how things work. We want to know how all this comes together. So let us so I want to experiment with this hit value variable. Okay, so that's pretty much it, right? So we have a array that's generated. We have a payload associated with it called the hit value variable. It's initialized to all zeros, but then it gets updated based on what happens when the ray traverses through the scene. Okay, so let us now get creative. So what I'm gonna do is I'm gonna initialize another variable. We're gonna call it hit value CUDA education. Okay, or maybe we'll do CUDA education hit value. All right, so we have CUDA education hit value. So we initialize it now. As I said initially in the video, it's a compileshaders.py thing that we use to basically compile this shader. Remember, this shader is external. Let me save it. This shader is external to our ray tracing basic script. Okay, so we have to compile this thing now. Based on my experience, I mean, I'll try and compile it now, but I think what happens is that if this shader, if this external shader thing is not kosher, if it's not if the ducks aren't lined up in a row, when you try to compile, it will tell you that like we're not able to compile. There are errors. It's doing all kind of stuff. So I'm kind of slowly building a respect for these external shaders and just how comprehensive they are. I just thought it was a thing that like it compiled and it didn't care what was actually happening in the overall script, but it apparently it in the compilation process it's very aware of what's what. So I know that when I was playing around with it, right? So basically, when you run the Python compileshaders.py thing, it basically says linking ray generation stage, missing entry point. Each stage requires one entry point. So that's the thing about Vulkan, where right each right right okay no it says location. Overlapping use of location 0, right? So that's the error. Location, raygen.rgen, and then line 13. Location, overlapping use of location 0. Error, 1 compilation errors, no code generated. Linking ray generation stage, missing entry point. Each stage requires 1 entry point. SPIR-V is not generated for failed compiler link. Okay, so this whole conversation actually is pretty aware of what's going on, right? So I am so anyway, so the moral of the story is this CUDA education hit value, we can't have it at location 0. I'm just for argument's sake, I'm gonna put it at a different location, right? And let's see if it compiles. Okay, so I put it at a different location, I make sure it's saved, and then I'm gonna compile again. I'm just putting it at location 1. Now, I know it doesn't make sense in all that we're doing and what have you, but that's all right, right? I just what I want to do is I want to mess around with this right here. I want to mess around with this right here and basically see what happens, right? So I'm going to change this from hit value to CUDA education hit value, right? See if the script runs. See if, I kind of already know what's going to happen, but, we really need to internalize what this hit value is, right? And what it's doing. Okay, so it compiles successfully. So when we run the script now, well, I gotta change this, right? So CUDA education, right? It's probably not going to run because, and I'll tell you why. Oh, I have to recompile, of course. I have to recompile because I changed the value here. It probably won't run though because we haven't initialized, we haven't put the zeros in, right? So let's just do it step by step. So we initialized another variable, CUDA education hitValue, and we've also we initialized another variable, and then we've put it in here. We didn't put the zeros in for CUDA education hitValue, but that's fine. All right, so then when we run it, oh, we get something. I don't know what this is. I swear to God, guys, I don't know what this is. I didn't actually run it. I didn't actually run it with I don't know, Disco Nights. Is this Disco Nights? Vulkan gone Disco Nights now? Well, you done with you finished with computer graphics? You gone Disco Nights now? Is that we're partying? Oh, this could be a really good strobe, guys. Listen, for all you guys that like to party, this is a really good strobe. I'm telling you. See, we inventing stuff around here, man. We're changing the world. CUDA education is changing the world. Okay, one script at a time. Anyway, all right. So that ain't gonna work. All right, so let's now initialize. Let's just put all zeros into our thing right here. All right, so we have CUDA education hitValue 0, 0, right? And let's see what happens. So we're gonna recompile. Well, I gotta save it. And then we're gonna recompile. Gonna save it. We're gonna recompile now, right? So we're now recompiling, and then we're gonna see what happens here. All right, so that's done. Okay, so look what we get. We get basically nothing, not even a sky model. Okay. I don't have. I mean, I understand why the triangle doesn't show, right? I understand that. I don't necessarily have an explanation for why the sky model doesn't show. The sky model is the background, the blue background that we that's like the default, right? That's like, I guess, the mist shader thing. But the moral of this story is basically that this hitValue variable, I believe, is used in other shaders and other scripts, right? So hitValue. Okay, all right. So I believe what happens is that this hitValue variable is being used in other scripts. So the other scripts now, like the closest hit and the miss and all that, is probably trying to update hitValue, but the image store function is basically writing to CUDA education hitValue, right? So if we go to, see, if we go to our miss, so now we're at our miss shader. If you go to the miss shader, notice that it's updating hitValue, right? But we have yeah. But we have CUDA education hitValue, right? So this guy, right? So this image store function is only looking at what the it's only looking at what the what CUDA education hit value is. So this basically never gets updated. Like it's 0, 0 here, but it never gets updated because all the other shaders are pointing to hit value, right? So the CUDA education hit value, it's there, it's associated with the image store, and it never gets updated. This image store function, in terms of like information, it never gets updated. So that's why the script runs. Well, that's that's important to know that it runs. Okay, we're at 120p FPS and all that. It runs, but we have a blank screen. We don't even have the sky model, or we don't have anything else. Now, another experiment that we could do is like start to play around with the closest hit. So do I want to do this on the video? I might crash the system. I don't know. I like to do stuff before I actually do it, but I'll make another video. Should I make another video? Yeah, I'll make another video. I think it's best if I make another video. I want this to be cohesive. But basically what happens is that this image store function is associated with CUDA education hit value, and it's reading this this CUDA education hit value variable, but nothing happens with it because it's not mentioned in the other shaders, right? In the miss or the closest hit. So because it's not mentioned in the shaders, it never gets updated, and we have a blank screen, right? Not even the blue. Remember the blue in the background behind the triangle? Not even that shows, right? So now, guys, we've kind of understood what the hit value variable is for and what it's all about, right? So we've actually learned something today. And it's pretty interesting. I'm going to put everything back to the way it was because I don't want to lose my triangle and lose our thing. So I'm recompiling now with the I'm recompiling with just the default information, right? So once we have that, we should get back our triangle, right? Because everything lines up. We have hit value here. We have hit value here. The miss is referencing hit value, and the closest hit is referencing hit value, right? So we should get our triangle back. Okay, so now we could just directly run the script, right? And we get back our triangle, right? So now we understand this hit value situation. rayPayloadEXT basically is talking about, hey, we're gonna shoot a ray and we're gonna associate a payload with it. The payload is hit value. It's initially empty, but we expect that the other shaders are going to update this hit value variable, and when we update it, it's going to give us our color in the triangle. So when it hits, it's going to be recorded that at this place there was a hit. At this place there was a hit, and therefore put this color here. At this place there was a hit, and therefore put this color here. At this place there was a hit, and therefore put this color here. There were no hits, put this color here. Here there were no hits, put this color here. Here there were no hits, put this color here. Here there were no hits, put this color here. All right, so that is the story for this video. Guys, if you want to join in and learn ray tracing Vulkan, tutorial number 1 and tutorial number 13, link down below. Get them. You could also get the whole Vulkan series. It assumes you have a Windows-based machine with a Vulkan-capable GPU. If you want to be able to run these ray tracing examples, you got to make sure your machine has a GPU that's ray tracing capable. For NVIDIA, it's RTX and above. I don't know anything about AMD or Intel. But for NVIDIA, if you want to get the ray tracing capabilities, you have to have RTX or above, right? To have the ray tracing stuff, be able to generate the triangle through the ray tracing stuff, all right? So anyway, that's it for this video, guys. Tell your friends, get together. You guys work on this stuff as a group. It's a lot of moving parts, a lot of things. Next video I'm gonna mess around with the other shaders just to see what happens with as it relates to the hit value. So I still want to go over like maybe some other stuff here, but I am gonna follow this hit value thread to see what happens. The last thing I'd want to highlight too is that this rayPayloadEXT, it's of type rayPayloadEXT, so that's very important, right? It's rayPayloadEXT. It's a very important piece of this puzzle. You have to have this rayPayload ext. It basically makes this variable associated with the ray and as part of the payload, right? And it gets updated by the other shaders. And all right, guys, tutorial number 1 installs the Vulkan SDK. Tutorial number 13 installs all these examples, the solution, and everything. All right. Thank you guys for watching. Have a great day.